Graphing polynomials. This PowerPoint and video explains a bunch of characteristics about graphs. We are not graphing yet in our graphing calculators, but we're going to be able to look at functions and identify a whole sort of things. So first, you need to learn all the things we're looking for. The domain of a function or a polynomial is a set of all input values, all the x values, and the range is the set of output values y. And every time we write the domain and range, it is in interval notation. So if you remember interval notation, since we did this with quadratics, that's when we said negative infinity to infinity, or we could have said 4 to infinity with parentheses and brackets. These are examples of interval notation. A polynomial is considered to be increasing when the graph increases when you look at it left to right. Therefore, it decreases when, as you go left to right, the function decreases. Now, the increasing and decreasing values are also written as an interval, just like the domain and range. So here's the hard part. It's in terms of the x. Okay, so we're going to write it in terms of x instead of y. So this is kind of difficult. So if you look at the function below, we have a minimum point right here at 0. I know the graph's not that great, but at 0, it stops decreasing and starts increasing. So as we start, if we were to start on this left side and read to our right side, the first thing it does is decrease. And it decreases all the way to that line at 0. Then after that, it starts to increase and go up forever. So a lot of people want to say, like, give me this y value down here, but I don't want that. I don't want to know how far down it's decreasing. I just want to know how far it decreased left to right. So if this is the origin is where it changed down here, then we say it decreased from, I'm going to get rid of this inequality notation. So it decreased from negative infinity to 0, and then we're actually going to put a parenthesis on 0 because at this point down here where it stops decreasing, at the x value 0, it's not decreasing or increasing. It's a minimum, so it's changing one and starting the other. That's why we use a parenthesis all the time with increasing and decreasing intervals. Then it starts increasing from that same value 0 up to infinity. Now, this is a tough concept, so it is going to take some practice to perfect it. So just know that as you're doing practice problems. All right, so a minimum is a point where the function changes from that increasing to or decreasing from increasing, which creates a low point on the graph. And a maximum is the opposite, from when it's increasing and all of a sudden it's starting to decrease, therefore it's a high point on the graph. We already know this because we've talked about mins and maxes related to quadratic functions, which is a polynomial. However, here's the addition. Now, if there's a min or max, we consider it a relative min or max, meaning we are going to identify this change in direction of the function. So we're going to be able to talk about all of the mins and maxes relative to the function. So there's another part to this. If a min or maximum is determined by our y values, it's either high or low. However, we write it as a point. So please, make sure you're telling me, the maximum is at 2, 3, okay? We're going to do that for our sake, but sometimes you will see Some of your teachers might have just had you give the y value. That is allowed. I'm going to ask you to write it as a point just to keep everything in similar format. So I'm not saying it's not allowed to just give me the y value, but for me, I'd like you to give me the point. Okay, so there may be more than one. So we can have a polynomial that's going to look like this, and all of a sudden we have a maximum and a minimum. So there can be more than one. However, if it's the lowest point on the graph, we call it an absolute min. It is absolutely the lowest point. If it's the highest point, we call it an absolute max, the highest point, meaning there's no other point that is lower or higher, hence the name absolute. So let me draw a picture of that for you. If I erase this. All right, so if I gave you the function and it kind of looks like this, this is a polynomial. You can see that right here we have a minimum, but right here is another minimum. That is lower than the first one I identified, so that one I circled is considered an absolute minimum. Okay? However, if you look at this point right here, this minimum, we still call it relative, and this one we still call relative, but then we go one step further and call that one absolute. Now, this right here, I'm going to box it just to try to be different. That is a maximum. We all know what that looks like. However, it is just a relative max. We cannot call it an absolute max, even though there's only one. These arrows indicate the function is going to go up. It's already past this point right here. So all of these points up here on the graph, and if it were to go higher, is already higher than that point. That is why it is not an absolute. Okay, if we do end behavior, all right, so it is just that. What is happening at the end? So you always start at the origin, 0, 0, and when you go to the left, all right, so when you go to this side of the function, is the graph going up or down? And then you say, okay, that's the one side. Now the other side, if I go to the right, is it going up or down? So we can figure out the end behavior without even looking at the graph, okay? So the degree and the sign, meaning whether it's positive or negative, of the lead term, which we know what that is, tells us the end behavior of the graph. If the degree is even, then the end behaviors, both sides, are in the same direction. So they're either both going up or they're both going down. If the degree is odd, then the end behaviors are doing the opposite. All right, so let me give you an example. If we had x cubed, I need to write it in a certain spot, x cubed plus 2x minus 1. This is a cubic trinomial. I really only care about the lead term when I'm doing end behavior. So the fact that the first term is positive tells me what I'm going to do on the right side, okay? So it tells me what I'm going to do at the end. That's why over here I said think end. So it's going to go up on that right side, okay? Then, because it's odd, and because of what we just said right here, they have to be opposite. So we start on the left side at the beginning of the graph on the left, down. So when you graph this, on the left it's going down and on the right it's going to go up. All right, so we've kind of seen multiplicity before, and I told you we were going to talk about it, so here it is. The number of times a given polynomial equation has a root at a given point. So if we were given this right here, this binomial, x plus 2 squared, It has a root at -2, what we know, but now we can say it has a multiplicity of 2, meaning there are 2 roots at 2. Okay? Then, for the next one, it has a root at 1, but it has a multiplicity of 3. X to the 4th at 0, but it has a multiplicity of 4. So what am I talking about? Well, when we were factoring, say you had x squared and then x plus 1, x minus 2 when you factored, okay? You know at the beginning you needed 4 answers, right? But this first one gives you x equals 0. This one gives you x equals -1, and this one gives you x equals 2. That's only 3. But remember I said, since it's a quadratic, we actually write 0 twice. That's because it has a multiplicity of 2, meaning there's multiple roots at that x value. So we can actually identify multiplicity graphically. Anytime you see a polynomial, do this right here, this little bounce, which I call it, or it looks like a quadratic. This is a multiplicity of 2. Anytime it goes straight through the graph, that's just a multiplicity of 1. It's just one root, kind of like we always have known. But where it gets tricky is where it looks like 3. Do you see how right here on the second graph at 4, it kind of looks like it's snaking through? It's kind of like S-curves through. That's a multiplicity of 3. Now, when you get into other classes, they're going to call this odd because it could be 3, 5, 7, 9, or more. However, we're only going to deal with multiplicities of 1, 2, and 3. So we're going to say that that's a multiplicity of 3. And then this one, since it bounces, has a multiplicity of 2. So that means I have a cubic function here because this root is there twice, this one's there 3 times, and even though if I solve I only get 2 numbers, multiplicity gives me 5 actual roots. Alright, so we have talked about this before. Zeros. The solution to the function where we intersect the x-axis, we call them the 0. The degree of the polynomial tells us how many zeros there are. They can be real or non-real, so don't get worried about finding I is okay. So if I gave you this example, x to the 3rd plus 2x minus 1, we see that this is a degree of 3, which is why there will be 3 zeros when I solve. Now, that also includes multiplicity, what we just talked about. Alright, so almost finished here. So we're going to talk about the maximum number of terms a polynomial can have. A polynomial has a max number of terms, 1 less than the value of the degree. So if I gave you that same example where it was x cubed plus 2x minus 1, the degree is 3, 1 less than 3 is 2. So the maximum number of terms, it doesn't have to have 2, but the most it can have is 2. Alright, so here's an example of kind of tying everything together. One more time, we're going to use that same example. X cubed plus 2x minus 1. Alright, so like we said, it has 3 zeros because 3 in my exponent. Because the first term is positive, I end going up on the right side. Because it's odd, the end behavior has to be opposite, so on the left it goes down. Then the maximum number of terms it can have is 2, which is 1 less than 3. And if I were to graph this in my calculator, this is what it would look like.